Okay, all right. So the first question is, what is the exact number of bytes in a system that contains 32 bytes, 64 megabytes, and 6.4 gigabytes? Okay, so with the whole byte system, 1 kilobyte is 4 significant numbers, 1 megabyte is 7 significant numbers, a gigabyte is 10 significant numbers, and pretty much the closest is pretty much like a flat down zeros. So a kilobyte is 1,000, and the closest to 1,000 is 1,024. And the best way how we can get to 1,024 is having 2 to the power of 10, and pretty much adding 10 to our exponent while going up. So 2 to the power of 10 is 1,024, close to 1,000. 2 to the power of 20, that's the closest to 1,000,000. And 2 to the power of 30, that's closest to 1,000,000,000. And that is how the system works in general for that. So for the first question, 32 times 1,024 equals 32,768, which is the closest to 32 kilobytes. And for the next question, 64 times 1,048,576 equals 67,108,864. And for the last one, as you can see, is flat down what it's supposed to be. Pretty much how it works is you multiply what that number is by its original value, which gives you what you need. So if the question was 50 kilobytes, you would do 50 times 1,048. 50 times 1,024 to get you 50,000 in decimal points. That's for question 1. Okay. All right. Question 2 goes over converting the following numbers with indicated bases to decimal. Okay. So what I did here, because the first things first, is having it in your base value, which is right here, base 5. And how you do this is it goes by points. So 0 is 0, next significant number is 1, next significant number is 2, next significant number is 3. So pretty much whatever number is there, it multiplies by that. So the first things first you want to do, the base number will be multiplying by the points on top right here, which is the significant numbers. So pretty much first right here will be 5 times 0. 5 times 0 is 1. Then it's 5 times 1, that's 5. And then it's 5 to the power of 2, that's 25. And then that's 5 to the power of 3, which is 125. After you get your base time your significant points up here, you go ahead and you put in the points in here. So first things first, I did 4 times 125, because that's the fourth value right here, the fourth number. So, and then I did 3 times 25 right here, as you can see lined up right here. After you get your base value multiplied with these right here, you go ahead and you add them all up right here. And then this is how you get your next base 10 value right here. Same goes for these as well. The order operation you go is you pretty much first things first, you put down your your significant points. I cannot recall what it's called. I just know exactly the process is that the first number is 0, and then you go on forward. 0, 1, 2. And then you do 2 times 0, 2 times 1, 2 times 2. And then you get your values here. And then after you get your values right here, you then go ahead and multiply what you got here with the numbers inside the base. So 8 times 1. 9 times 12, 1 times 144, etc. Okay, that's question 2. Question 3. We go ahead and where it says, what is the largest number that can be expressed with 16 bits? What are the equivalent decimals and hex decimal numbers? So, as it's saying, 16 bits. For binary, that's 16 points right there. Alright? That is 16. And then for decimal, that is yeah. So, and then for hex, that is the max point you can get on a 16 base. Right here is the 4 binary points, each one being the max. So pretty much for hex, that'd be F. So F, 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 F. That'd be the max for 16 right there. Okay. 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 So it says for question 4, it says determine the base of the numbers in each case of the following operations to be correct. Okay. So the first thing that I did was I did an unknown base, 14, an unknown base, and then I took 1 and 4. So 1 multiplied by the unknown base, and then 4 multiplied by 1. 4 is the unknown base, and 1 is 1, and so on and so forth. And I went ahead and did 14 base equals base plus 4, because I multiplied those and added those together, and it got me that right there. And then I went ahead and put the b plus 4 back into its original place. And what I did next was I took the 2 from the bottom and multiplied it from the outside so I can cancel them out. I canceled on both sides, so multiplied the 5 on the other side. Multiplied 2 on the other side and canceled the 2 down here. So then went ahead and got unknown base value plus 4 equals 10, because 5 times 2 is 10. I went ahead and subtracted 4 on both sides. That brought that down to 6. And removing here, which gives us b equals 6. Okay. And same process for these. All right, question 5. Question 5. It says, convert the hex decimal number 64 CD to binary, then convert it from binary to octal. Okay. Sorry. When back on this question, that's octal. I get the names mixed up. So right here, okay. So right here, we have, as I said, 64 CD. So in the order of how we got these is that under the binary numbers, so pretty much 0001 would be 1, 0010 that would be 2, 0 it goes there and so forth. And when you're going down that line, you get 6, and then when you get 6 and you get 4. And for C and D, we go ahead and put those into hex. So pretty much any number, when it hits 10 double digits, that's when they start being letters. So 10 is A, B is 11, and C is 12, D is 13. And for us to be able to put this in the decimal, we went ahead and pretty much counted all the way up from decimal, like all the way up. So pretty much like after 1100 is 12, and 12 is C, and 1101 is 13, and also D. So that's how we got that right there. So in binary right here, 0110, as you can see, and putting in an octal, 110010, 011001, as you can see right there. We got those because for octal it's a little bit different. This is pretty much the same thing as binary. It's just shortened by 1. So pretty much the same process. 001, that's 1. 010, that's 2. 011, that's 3. 100, 4. 101, that's 5. 110, that is 6. And that is how we got 6 right here and our other values right here. And then we have 64 CD. Okay, question 6. All right. It says, convert the decimal number 431 to binary in 2 ways. Convert directly to binary, convert first to hexadecimal, and then from hex into binary. Okay, so first things first. First things I gotta go over is we go ahead and divide 431 by 2. The process of that is so we can get a remainder. So pretty much we divide 431 divided by 2